Let's see how to graph a rational function with a slant asymptote. For example, let's graph this function here. The first thing to notice is that this function is in simplest form. The numerator and denominator do not have any common factors. So let's start by finding any asymptotes of its graph. We'll begin with vertical asymptotes. A rational function in simplest form has vertical asymptotes at the zeros of the denominator. And looking at our function, our denominator will be 0 when x is equal to 2, which means that the graph of this function does have a vertical asymptote given by the equation x equal to 2. What about any horizontal asymptotes? Well, let's first notice that the degree of the numerator is equal to 2, and the degree of the denominator is equal to 1. And therefore, the degree of the numerator is greater than the degree of the denominator. And therefore, in this case, there is no horizontal asymptote, so there's none here. Now, are there any other types of asymptotes? There is. This function has what we call a slant asymptote. Looking down here, not only is the degree of the numerator greater than the degree of the denominator, it's exactly 1 bigger. And with rational functions, when the degree of the numerator is equal to the degree of the denominator plus 1, the graph will have a slant or oblique asymptote. A slant or oblique asymptote is a non-vertical or non-horizontal line that the rational function behaves like as x increases or decreases without bound. And with rational functions, this asymptote can be found by long division. So let's divide. X goes into x squared, x times, and x times x minus 2 is x squared minus 2x. And then when we subtract, we have negative 3x minus a minus 2x, which is negative x. And then we still have the minus 2. X goes into negative x, negative 1 times. And negative 1 times x minus 2 is negative x plus 2. And when we subtract, we get negative 4, which means by the division algorithm that our function is equal to the quotient, or x minus 1, plus the remainder divided by the divisor. And as x increases or decreases without bound, this is going to get really, really, really small. In fact, it's going to go to 0. And therefore, our function will start behaving like y equal x minus 1, which is the slant asymptote. So y equal x minus 1 is a slant asymptote of this graph. So we have this slant asymptote here, And we found we have this vertical asymptote, x equal to 2, and that there was not a horizontal asymptote. And now that we have our asymptotes, let's find a few points on our graph on either side of this vertical asymptote here. So we have x and y. So when x is equal to 3, for example, we can plug 3 into our function, and we get 3 squared minus 3 times 3 minus 2, which is 9 minus 9, or 0, minus 2, which is negative 2, divided by 3 minus 2, which is 1. So the ratio will be negative 2. When x is equal to 4, we get 4 squared, which is 16, minus 3 times 4, which is 12. And 16 minus 12 is equal to 4. And then minus 2 is 2. So the numerator is 2. But so is the denominator, isn't it? We'll have 4 minus 2. So the ratio will be 1. And when x is equal to 1, we get 1 squared, which is 1, minus 3 times 1. So 1 minus 3 is negative 2. Minus 2 is negative 4. And the denominator will be negative 1. So the ratio will be positive 4. And when x is equal to 0, we have 0 minus 0 and then minus 2. So the numerator is negative 2. And the denominator is also negative 2, isn't it? So the ratio is 1. So using all this information, we get our graph. This is our vertical asymptote here, x equal to 2. And notice here, as x approaches 2 from the left-hand side, our function increases without bound. And as x approaches 2 from the right-hand side, our function decreases without bound. And here's our slant asymptote here. Y is equal to x minus 1. Notice it has a y-intercept of negative 1 and a slope of 1. And as x increases without bound, the function starts behaving like this line. And as x decreases without bound, the function starts behaving like this line. And here are the points that we found. X equal to 3, y equal to negative 2 is here. X equal to 4, y equal to 1 is here. X equal to 1, y equal to 4 is here. And x equal to 0, y equal to 1 is here. And this is how we graph rational functions with slant asymptotes. Thank you, and we'll see you next time.